So, this is supposed to be Unit 6, not Unit 4. And this is supposed to say, ladies and gentlemen, relations, not relate. I don't even know how to say this. Is that A's? Relata ions? No, that's not what it's supposed to say. It's Unit 6, not Unit 4, and it's relations, not relata ions. And some of what we're going to do, most of what we do today should be review, but we'll make sure we're all on the same page here. So flip the page if you haven't already. Hands up if you've done any graphing at all in middle school. Some hands, I've seen some hands. Okay, cool. So today's going to be some review. Here we go.
That's right, we did dot pictures. Those are so annoying. We had to draw our own graphing picture. And actually it was helpful, but oh my god, that was so annoying. I didn't make battleship.
Okay, are we good? Do some battleship. We played some dot drawings, okay? So let's go some definitions. Again, maybe this again, hopefully is a review. Get us all on the same page. The coordinate plane, what is it? Is that language you've heard before? What is a coordinate plane? Sorry, Carolyn? Yeah, it looks like that. Yeah. So, it's not a cross, but that's okay. So that's the definition. The coordinate plane, here's what the coordinate plane is. The coordinate plane is a two-dimensional. We talk about planes in math. I would help if I could spell anything today. Dimensional. Two-dimensional plane. In math, planes are 2D. It's a flat, this. This is the plane. Things are found in the plane. They're found in the flatness made by this. These are called axes. You can make these things three-dimensional if you like. You just stick one kind of like that. And now you've got a three-dimensional. It's not a plane anymore. You've actually got three different planes here. But the coordinate plane is a two-dimensional plane formed by a set of, and that doesn't say axes. That word is actually pronounced axes, the plural of axis. We'll get a little bit more technical. They don't have to always be x and y, but in this, generally, that's what we're going to do. The origin. Does anyone know this language, the origin, what that is? What do you mean? It's a starting point. Okay. But it's. Well, how do you know where this thing starts? Right there. Okay. So the origins where the axes intersect. Axes with an I is axis. That's one. Axes with an E is plural of axis. We can say here what you guys already said, where they start. I'm going to put start in quotes because that's weird. Because where do numbers start? Real. We'll get there. Would you like me to put 0 in brackets? Like this? That's coming later. But Danny wants it now, so we're going to put that in there now. The origin is 0, 0. It almost looks like two eyes. I should have put some pupils in there with the nose there. An ordered pair. What is an ordered pair? Coordinates, yes. What do the coordinates do? Sure, yeah. Coordinates that, actually, this should actually say, I'll say it this way, coordinates that give a location in the plane. That game Battleship. Yeah, that was like my childhood right there. A lot of Battleship. There's a lot of fun ways to play Battleship, but I'll tell you when you're older. The x coordinate does what? Yeah, moves you sideways. Sure, I'll put all those words in here. Sideways, horizontally, left and right. I can't fit those in there. Y does what? From the origin. We've already established the coordinates of the origin, 0, 0. That point right there. Does that make sense? Can 0 be positive or negative? What would that mean? I don't even know. You can't have negative nothing. There's just nothing. The x-axis, singular, is the which axis? Generally. Oh, I want the axis, not the coordinate. Okay, the horizontal axis. So which means the y-axis is the vertical axis. And someone said it already, so we're going to add it in here. What did you say? You said coordinates. One of you said that when you have a set of coordinates, the x one comes first. Did I make a mistake? Oh my gosh. Just so we're clear. I have a headache right now. We'll use that as my excuse. Horizontal axis, vertical axis. Coordinates x, y. X comes first, then y. I think I'm going to say it on the next page anyway. No, I didn't. I'll say it here. Do you guys talk about quadrants on this thing? Some yes, some no. Do you remember, Kyla, what they are? Okay, Nika, what did you just say? You'd think that would be correct, because quad generally means 4 of something. Well, is there a way that, is this thing kind of broken up into 4 here? Yeah. Okay, so it's the sections of the plane. So you've got here, this is the coordinate plane. We're doing some labeling here. This thing has a name, depending on. So we don't always have to use x and y. When we do choose to use x and y, we call this thing the Cartesian coordinate plane. Cartesian coordinate plane. So we generally talk about Cartesian coordinates being x and y. But they don't have to be. You can, instead of talking about where you are x and y, you could say, oh, I'm at this angle and I'm this far away. Like if you're 6 centimeters at 45 degrees, you might be out here. And I'm at like 270 degrees, which is going to be down there, some distance away, right? So you don't have to use x and y. That's where the idea of polar coordinates comes from. You group of girls who I was playing polar tic-tac-toe with a couple weeks ago. They were playing polar tic-tac-toe. Cartesian's x and y. Does anyone know where? Does that word there sound familiar at all? Cartesian? Are there other words that start with cart? Not a shopping cart. Sorry? Cartography. What is cartography? The making of maps. Does the making of maps have anything to do with? Grid, laying down a grid. Yeah. Those both, the science of cartography and the Cartesian coordinate plane were both created by a dude whose name, if you don't know already, you're going to learn now. First name was Rene. Does anyone know what the last name is going to be? Rene Descartes. There's accents on some of those E's. I have no idea which way they go. He was a Frenchman. He is now long dead. He was a philosopher. He was a map maker. He was a mathematician. He did all sorts of stuff. Because back in the day, if you did one thing, you kind of did everything. So Rene Descartes, he was also a philosopher who said his idea was, I think, therefore I am. If you've ever heard that phrase, that was one of his famous quotes. I think, therefore I am. Oh, I spelt it wrong. There's an S in there. Show me again. And there's an S at the end. Yes, I forgot the S's. And there's one accent right there. Bam. Thank you. Rene Descartes. I forgot the S's.
So is it Rene Descartes, or is it?
That's all one word.
It's all one thing.
And he's got awesome hair. And a pretty killer mustache. Yes. Let's do it. Rene Descartes.
Was he a good singer? I feel like he would be.
There he is.
That's like every hair ever.
He's got pretty fantastic hair. Yeah, that's great hair.
I'm not a fan of this one.
Okay. So that's the Cartesian coordinate plane developed by him. This is, let's get some different colors going on here. This is the y-axis. This is x. Which direction is typically positive? Hello and welcome. They should be in the printer. The printer, right at the back there. Excellent. Positive things are usually on the right and... But y doesn't go left and right, I mean, like, so the right, so yes, you're right, let's say this is positive. So we're going to label some things here. So this is going to be like 1, 2, 3, 4. But the y doesn't go positive, it doesn't go up, it doesn't go left or right, so let's go up or down. Which way is positive typically? Typically it's up. As long as you label it. So then this guy over here, this is the negative direction. -1, -2, just like a number line. Is this ringing bells? Have we seen this before? Okay, cool. So there's my grid, my plane. Typically this is, actually not typically, this is how we label the quadrants. We say this is quadrant 1. And in quadrant 1, you've got a set of coordinates that are all positive. X and Y are both positive. Here you've got quadrant 2, where you've got what? Negative and positive. Because remember, it goes X, then Y. Down here we've got quadrant 3. I know, it's always bothered me too, but it's the way it is. Where this is negative and negative. Where we've got a positive and negative going on there. So this is the XY plane. This is really boring. Let's spice it up a little bit here. We wouldn't be complete. We don't live in a two-dimensional world. Actually, feel free not to draw this. I'm not actually going to make you do this. But I'm going to draw it here now. Hopefully I don't screw this up. We've got X and we've got Y. Anyone want to take a guess at what that is? That's Z, yes.
Was that supposed to be a 45 degree?
No. So my Z-axis is going to go off like this. That's going to be 1, 2, 3, 4. So this is going to be -1, -2, -3, -4. And now we've got all of three-dimensional space here. So it only really makes sense to talk about, the XY plane if there are other planes to talk about. Otherwise, why would we call this the XY plane? It's just the plane. The reason we label it as the XY coordinate plane is because, so X and Y, that's the flatness of my paper here. I could have other coordinate planes though too. I could have YZ with these two axes here. The Z's going this way, the Y's going this way. So my plane then in the YZ direction is going to be like this thing here, like where my hand is. That would be that plane. Sorry? No, you're not going to be doing Z, but at least I want to introduce it to you. So when you do it at some point, you'll be like, oh yeah, maybe once upon a time, it kind of sounds familiar. Or you've got the XZ plane, which is kind of like this kind of flat into the paper kind of thing going on here. So you've got XY, we've got YZ, we've got XZ, and these three planes intersect with each other. Like this, to create for us our three-dimensional reality. Cool? See, look, there it is. Comments, questions, concerns so far? 4 dimensions get weird. We don't talk about 4 dimensions. Flip the page. So, let's start stating some coordinates here. Coordinate A. What are the coordinates of point A? Hands up. Kyla. Would it be 2, 1, as opposed to what else? Opposed to 1, 2, okay. Yeah, yes, they always go X, Y. So if then I'm over here with A, then I go 2 in the X direction, 1 in the Y direction. So yeah, that's going to be 2, 1. B is going to be, no. -2, 3. C, yeah, -4, -2. We cool with what's happening here so far? Point D is going to be some over here from the origin. To get to point D, I go over 1, 2, 3, 4 in the X, 1 on the Y. -1, sorry, on the Y. Point E is where? 0, 0. Point F is, love it. Point G is, cool. Comments, questions, concerns? This is ringing bells, yes? Vaguely familiar?
I just remember the 0.
Sorry?
Yeah.
You remember? Okay. Yes, 0 is important. Yeah, remembering why zeros are what they are is important. Okay, so let's graph these guys down here at the bottom. Where's point A going to be? You know what? Let's do it this way. Hands up for where point A is going to be. Not where is it going to be? Who wants to take a stab at it? Eminette. Yes, you. Go show us where A is. No, go show. Go show. Where's point A? Right there. Right here? Why there?
Because X is
Cool. Love it. There's A. Someone who wants to show us where B is. I'll start picking people. Yes, Nika. Where's B? So right there. Love it. I keep looking down expecting to see the shadow of your finger on my page, and it's not there. Who wants C? Angel, you want C? Is that what I heard?
No, I don't want to.
How about Akam or Armand? Either you guys want to do? Where's C? You need a tall person for C? Well, there's a meter stick. Come on, Ria. Where's C? Come on, Ria. Armand's got C. Okay, Armand, show her where C is. You should. So where? Right there? Okay. Okay, where's D? Yeah, Carolyn. No, for D, you're definitely tall enough for D. Yeah. E. Tammy, go for it. Ooh, is she right? Remember, they always go X then Y. So where's E going to be? Yeah. There you go. And F. Where's F going to be? Chelsea. Oh, my head hurts. More water. Love it. Cool. Comments, questions, concerns? We cool with this? Okay. Review. I want to make sure we're all good. So I'm gonna assign you some stuff, and then I'm gonna. Yes. I do have graph paper. So if you have your own graph paper, you're welcome to use your own graph paper. One can be done straight on the thing. For the rest of these, I do have graph paper for you. It's only expensive if you don't photocopy your own. Yeah. I don't have graph paper, but I have printer paper. Lots and lots of printer paper. This will be a little better. Okay, so I want you to try these out. I'll come around and make sure we're all on the same page here. This graph paper is double-sided. You do not have to, so like this is not like a science lab where you have to put like 0, 0 down the bottom part. You can do a bunch of pages on one. Just make sure you leave yourself enough space. Your grids are big enough as you're making them. We're cool with this. Comments, questions, concerns, launch into it. Okay, if you have your own graph paper, feel free to use it. If you don't, there's a whole bunch right here. Boom. There you go. I need to go get some water because I have a killer headache right now. This is so 0 in the X means you're here. 0 in the Y means you're anywhere over here. Oh, yes, you certainly did. Absolutely. Sure, go ahead. Don't have to.
Taylor's birthday is 5, 6, 7. His birthday is in May, and her birthday is 0, 5, 0, 6, 0, 7.
How's it going? What did you get? Shut up. Okay, bye-bye. Yeah. I know. So actually, it might be